In the previous chapter, you were using the z distribution. Now you're being introduced to a new distribution, and that requires a new critical value table for that distribution. This is the t distribution. The table is pretty easy to use. It's pretty obvious. I just want to point out key characteristics of it and also make sure that you're very clear on how to find your critical values. You use this table to find critical t values, just like you use the z table to find critical z values. All right, so in this table you'll see first of all the far left-hand column says df. That's, as you know now, stands for degrees of freedom. Degrees of freedom for a one-sample t-test, which is the test you're being guided to do in this chapter, is n minus 1. In other words, your sample size, if your sample size n equals 75, degrees of freedom for the one sample t-test is calculated as degrees of freedom equals n minus 1. So degrees of freedom, if your sample size is 75, will of course be 74. Very simple, right? Now, I emphasize this is for the one sample t-test because degrees of freedom will be calculated slightly differently for every test that you do. So you have to make sure that you're using the right little formula for determining degrees of freedom for your particular test. So let's look at this together. So here's your degrees of freedom. And let's say that you're trying to figure out degrees of freedom if you have, let's say you're trying to figure out your t critical value. If your degrees of freedom equals 21, that means what was your sample size? N equals 22, right? Okay, so your degrees of freedom is 21. And let's say that you're going to do a two-tailed test with alpha 0.05. Now, notice up across here, you have your alpha levels for a one-tail test, alpha levels for two-tail test. So you have to always be sure that you're looking at the right column and you're drawing your values from the right cell. And of course you're going to find the critical value will be located at the intersection of the degrees of freedom and the correct test that you're using. So let's say we're going to do n equals 22, degrees of freedom equals 21, your alpha value is 0.05, and you're using a two-tail test. Two tails. Okay, so let's find that value. Let's go to 0.05, two-tail alpha, right? And we go down to 21. All right, so here we have 21, two-tail alpha of 0.05, and your critical value is right here. You see it's 2.080. Easy, right? Let's find another one. Instead, let's say this time, gracious. Okay. Let's say this time that your sample size equals 10. And that means your degrees of freedom would be 9, right? And let's say you want an alpha level of 0.01. And let's say that you're going to use a one-tail test this time. Okay, now we discussed already how you have to be very, very careful if you decide to use a one-tail test, and it's not used very often. But let's just say for finding our critical values, that's what you decide to do. So if n equals 10 for a one-sample t-test, degrees of freedom is 9. So let's go up to 9. And alpha 0.01 for one-tail test. Here's one-tail alpha, 0.01. And you see that the t critical value is 2.821. Right? Right there. Got it? Pretty easy, right?